Okay, so remember, it's telling me first, right, I got to start, just like with order of operations, got to start with the stuff that's furthest inside, right, kind of work inside out. So I'm putting -1 into my g equation, right? So I'll have 4 times -1 minus 1. So -4 minus 1 gives me -5, right? And now I'm going to take that answer and put it into my f equation. So now I'm really trying to figure out what's f of -5. Right? So take the answer that I get here, put it into the f equation. When I do that, I get 3 times -5 all squared plus 4. Right? And then if I simplify that, -5 all squared is positive 25, so I really have 3 times 25 plus 4. 3 times 25 is 75, plus 4 is 79. So my f of g of -1 is 79. Awesome, looks like I was able to come up with that. More questions on how to get there? All right, so one thing I want to look at also on this, because sometimes it can get a little bit confusing when you're given charts or graphs and it's asking you still to find this same kind of a thing. So let's see here, I'll go to all right, so if we're looking at, let's see if that's going to make it a little bit bigger here, easier for you to see. So this isn't in your notes or anything like that. Just do these just as example problems. It just was easier to have the charts and stuff already written out here. So if we're looking at this first one here, right, and it's saying that I want to find f of g of -4, right? And then notice that it gives me up here, I have my, here's my f of x, right? And here's my g of x. So I need to be using both of these tables in figuring this out. So it's saying, you know, when g of -4, trying to figure out what g of -4 is, take that answer and put it into the f, right? So sometimes, sometimes this makes more sense to students. So if I'm taking -4 and I'm putting it into my g, right? I want you to look over here at the other, this g of x table, right? So this is saying when x is -4, g of x is 5, right? So that's what I'm going to get out is 5. But then I'm not done, right? Now I'm going to take that 5 and I'm going to put it into the f equation. So when I look over here, when x is 5, my answer is -1.6. Okay, so that would be my answer. That is my f of g of -4. Okay, so now I want you guys to use these same tables, right? But I want you to now do this part B. So now do it the other way. Do g of f of -4 and see what you come up with there. I'm going to erase some of the stuff that I put up here. Okay, type in what you get for your answer in the chat box when you get it so I can see what you guys are coming up with there. Okay, awesome. Looks like you guys definitely have the hang of this with the charts, right? So put put -4. Whoops. So -4 into f. So I'm looking at my f one here, right? And then 5 comes out. And then when I put 5 into in place of x and my g of x, then 12 comes out. So that's how we got 12 for the answer, if some of you didn't get there. Okay, and then you can do things like f of -4, right? So that's just saying put -4 into the f equation and then back into the f equation, right? Or sometimes they'll say g of g, right? So sometimes you'll be using that same function that you'll be putting it back into, okay?
What about on example, the third one up? It was, D.
Okay, yeah, D is a good one to look at. I'm glad you brought that up. Okay, so what happens on this one? What did you find? Why did you ask specifically about that one?
Because there's no value on g of x.
Yeah. So sometimes if that happens, then the answer is there's not enough information. Okay, so like on this one, what he's saying is if you try and do f of, the -1.6, you get 0. But then when I try and put 0 into my g, there's no 0 there for x, so I can't find a value to come up with. So on this one, I would say not enough information. Right? Because this is only part of what that, the values for those functions. It's not all of the values, they're just giving you part of it. And the part that they give you does not give you enough information. Thank you for bringing that up. That's a good one to look at there. Okay, let's look at some with some graphs now, because I know sometimes that can be a little bit challenging too. Right, so here the first one on the left side, right, this is my f, and then my other equation over here, right, this one's my g, so it's just making sure, oh, let me change those. Okay, so I've got f and g on each of those. Just make sure you know which one's which when you're looking at your graphs. And so then kind of the same type of thing is happening here, but let me show you how I would look at this one. So again, on part A, it says find f of g of 2. So I'm trying to figure out, in the g of, the g graph when x is 2, right? So I'm looking over here and I'm saying, okay, here is where x is 2. And sometimes I'd have to go up or down to figure out where it's going to be touching my graph. This one I didn't, so that one is just g of 2, right? When x is 2 on this graph, the y is 0. So then I'm looking, so let me write it down this way. So g of 2 is 0, and then I just need to figure out, okay, now what's f of 0? Right, so I go over here, and when x is 0, then my y would be 3. And so my answer there is 3. Does that make sense, or is that kind of weird? You guys following that with me? Or let's see if I can make this a little bit smaller. So don't worry about doing B and C right now, but I want you to try doing part D. So g of f of -4. Right, so where do you try that one? Using those graphs, so it's g of f of -4. And then put your answer into the chat, what you come up with, but don't hit enter quite yet. I'll have you guys all hit enter together. Okay, go ahead and some of you guys hit enter. See what you came up with. Okay, looks like most of you are coming up with 0. Not everybody answered there, but let's see, how would you come up with 0 on that, right? Remember, we're putting change this color, that's kind of hard to see. I'm going to put the -4 into the f equation, right? So I'm looking at the one on the left first. So I'm thinking, okay, so when x is -4, that's here, right? And then I'm kind of looking, where does that cross my graph? And that would be right here, right? And so that looks like it's just a little bit, I don't know, it's pretty close to 2 there, right? And then I'm putting 2, right? So let me write this down here. So f of -4 equals 2. So then I'm figuring out what g of 2 is. And remember, that was right here. So that would be 0. Okay? And sometimes these graphs are off a little bit on this little, these notes and stuff that I'm going to show you today, but the ones on your homework will not be. They'll come out to be these whole number answers, so they'll be easy to tell that that's what they're looking for. Okay. What questions can I help you understand better about these composite functions, whether they give you the equations, whether they give you a table, or whether they give you a graph? Right, because they'll ask you in those 3 ways. Okay, I want you to try one more here. So this is just this function f, but I want you to try just the part C down here. Okay, so what's f of f of f of 3, right? So we've got 3 of them this time. F of f of f of 3. Okay, so go ahead and take just a couple minutes and see what you come up with there. Okay, so when we do this first one, right, f of 3, right, so when x is 3, what is y? Well, that would be 0, right? So then I take that 0 and I find what's f of 0, right? When I find f of 0, remember I'm looking, so here is where x, right, is 0. And where does that cross my graph? It crosses it up here at 2. So f of 0 is 2. And then I'm trying to find what f of 2 is, right? So f of 2, I do this, right? So over 2, what comes out? 3. Did you guys get 3 for your answer on that? Okay. So sometimes it can get a little bit confusing just when they're doing the same function over and over and over again, but it's still all the same idea, right, on that. Okay. All right, let's look at something else that you're going to be talking about on 8.1. You're also going to be talking about something called inverses, right? And understanding what an inverse function is going to kind of help you understand a little bit more about what we're going to call one-to-one functions. Let me see, I'm going to go change this. All right, so here is a graph, right? And it gives me a table of values, right, for the f of t function on here. So I can see at 0, 0, right, that's one of the points on the graph. 1, 1/2, so over 1, up a half, that's also on that line, right? 3, 3 is here, and then 5, 4 is here, okay? And so what I want you to understand about inverse functions is that really what you're doing with inverse functions is you're just switching the x and the y, okay? So I'm just going to put over here switch. I mean, I guess it's not always going to be x's and y's, right? But your input and your output, I guess, might be a better way to say that. Because like on this one, we have t and f of t. But notice, right, on my inverse function, what's happening is, do you see how all of my f of t's are now here in this t column, right? So they changed the y values, right, the f of t values in this one. Right, so like my outputs became my inputs. And then I need to make my inputs, change my inputs here to my outputs. Right, so they're going to go in this one. So this one's still going to be 0, 0, right, since those are both the same thing. But then instead of being 1 and 1/2, it'll be 1/2 and 1. 3, 3, and then 4, 5. Okay? And then what I want you to do is I want you to graph this. I'm going to give you a couple minutes because I want you to graph this on your notes. So you only need to go out, 6 in each direction there. And first graph, what we have for our f of t. And then I want you to graph what we have for our this f to the -1 power of t really is said the inverse of f of t. So I'm going to write that above it here. So it says the inverse of f of t. Okay, and then after you've made this, so I made it kind of like an orange graph. It doesn't look as good as the black line that was already on there, but just to help you see the difference here, right? So there's the one, the f of t, and then when I graph the inverse of f of t, I'm going to do that in purple so we can kind of see the difference between these. All right, and I'm still just going to plot these points. So I still have 0, 0, right? And then 1/2, 1, so over a half up 1 would be about there. And then 3, 3 will be here. And then 4, 5 about there. Okay, and so then when I try and, you know, like connect these dots back together again, it's going to look something kind of like this. So it's going to go up, and then, oopsie. All right, my graph doesn't look super awesome, but hopefully you can kind of get the idea here of what's happening. Because what happens is that anytime you graph a function and its inverse, they're always going to be, let's see here, what happened here? Did I leave out a point here? Oh, sometimes it's a little bit easier to put another point in there because I'm like, that one looks really weird. Let me try this again. Sorry, I don't like the way that one looks. Let me get rid of my... Wow, this is not my favorite. This is why I like using the that I already use usually. Okay, so let's try doing one other one because we can see another point here that wasn't put in our table, but do you see there's a point there at 2, 2? And that will actually make graphing our inverse a little bit easier. So 2, 2, and then when we switch it, it's still 2, 2, right? So let me try this again. So there's the 0, 0, and then the 1/2, 1, and the 2, 2, 3, 3, and 4, 5. Make it a little bit easier to follow here. So it's going up like this, right? Kind of coming through here, and up, kind of continuing out like that. Because what's happening here that I tried to make with this other, just do like maybe a green line here or something. So it's supposed to be, if you were to fold it over this little dotted line here, right? And this is the line y equals x. So it's always the same line that these, you know, an inverse and it, you know, the function and its inverse are going to be reflected across. Meaning, imagine if I tried to fold this graph on that dotted line, then our, you know, the orange part of the graph and the purple part of the graph would land on top of each other. Okay, is what's happening there. So when we're dealing with inverses, right, we can always tell by graphing them if they're inverses of each other because they'll always be symmetric to this line y equals x. Right? They'll be reflected over it. Okay. Any questions on that? I know my pictures don't look all that spectacular, but I hope you're understanding what I'm meaning there. Okay, so just a couple of things that I want to, you know, have you write down in your notes because these are a few things that, you know, are important to know here. Is that to plot the inverse of a function, switch the input and the output. All right. I'm going to say x and y because that's what we usually call them, right? And then plot those points. Okay, and the other thing that I want to make sure is clear is a graph and its inverse are reflections over the line y equals x. Okay, and sometimes they call that symmetric to the origin. You might hear that in 1050 a lot, that they'll talk about that. And that's what they mean. If they say it's symmetric to the origin, just means it's being reflected across that line y equals x. Okay. And then just a few things that I want to talk about too is let's look. So remember when we talked about functions at the very beginning of the semester, we said that, you know, something is a function. I'll write these things down here just to remind us again. All right, so something, let's see, is a function when x is unique, right? So the x's can't be repeated. Also, we said that when we look at a graph, it passes the vertical line test. Right? If we put a vertical line anywhere on the graph, it can only hit it once. That's what the vertical line test is. If it hits it in two places, then it's not a function. Right? And then the other thing that we said about functions is that every input has an output. And so remember, we talked about this when we were talking about like those vending machines and how when you put something in, right, you have to know what's going to come out, because, you know, if you put an input in and then you're like, I don't know if I'm getting chips or a Snickers bar, right? Well, that wouldn't be a function. But every input has to have an output also on that. Okay? So I want you to look at these. So if we are looking at this first one here, right, would you say this first one is a function or not? Okay, so does it follow these things? Are the x's unique? Yeah. Right, none of the x's are repeated. Does it pass the vertical line test? Well, we can't really tell because it's not a graph of it, so we'll skip over that one. But every input has an output, right? So yeah, that one is a function. So when something is a function, right, then we can find the inverse of that. So I want you to try and do something for me here. So I want you to make another little chart. So maybe make that chart and then another little chart next to it or underneath it, however you want to do this. Okay, and here I want you to do x and then the inverse of g of x. Right, so remember we say the inverse of g of x by saying g to the negative 1 power of x. But that's red, the inverse of g of x. Okay, so go ahead and find those values there. And then I want you to do the same thing on the h of x one, right? So x and then the inverse of h of x. Okay, so remember, your inputs are becoming your outputs are becoming your inputs, right? So you're just switching these. So on the top line, we'd have 9, 1, it's still going to stay 2, 2, and then 5, 3. Okay. Now, is this still a function? So is this inverse of g of x? Would you guys say that's a function or not a function? Yeah, this is a function still. Okay, let's look at this next one. So again, if we're switching our input and our output, then we're going to have 9, 1, 9, 2, and 5, 3. So now, is this one a function? No. Yeah, you guys are right. It's not a function, right? And you can tell because our x's are not unique. We don't know whether 9's going to 1 or 2. It's kind of like if we press 9 on the, vending machine, are we going to get some chips or a Snickers bar? We don't know, right? So that one is not a function, okay? So we're going to be talking about something called inverse functions, right? And with inverse functions, so when you have, a function like we talked about here, right, and we can find the inverse of a function and it's still a function, then we call those one-to-one functions. Okay, so this first one here, right, since it was still a function when we found the inverse, this is a one-to-one function, right? And this one is not, right, because we don't know, because it doesn't come out to be a function there when we find the inverse of it. Okay, so really what is happening there is that you can only find the inverse of one-to-one functions, right, when we're actually looking at an equation. So let me write that down over here because this is something important to remember, right? You can only find the inverse of one-to-one functions. And again, it's for that same idea of what we were talking about here. We don't know whether 9 is going to 1 or whether 9 is going to 2. And so we can't write a function for it if that is the case. Okay? So, and then we're going to talk about something called the horizontal line test now. Okay? So when we have, so I'm just going to give you a little function here, right? A few different things. So if I have this, right? If I have this, I have something like this. Okay, so I want you to, look at these and we're going to see, do they pass the vertical line test and the horizontal line test? Because if they do, then that means they're one-to-one functions, right? So on this first one, that parabola, right? So if we first have to establish it's a function, right? And it only hits in one place, so it is a function, right? But now if I do the horizontal line test, right, and go this way, then it hits in 2 places. So this is a function, but not a one-to-one function. Right, so I'm going to write down this is a function, but not one-to-one. Okay, what do you think about that second one? Okay, yeah, it's not a function, right? So if you start off trying to do the vertical line test, right, it fails that vertical line test So there's no way it can be a one-to-one function because it's not even a function, right? So it's not a function. So it can't be one-to-one. Right, but what about this last one here? Right, so if I do my vertical line test, no matter where I put a vertical line, it's only going to hit in one place. What about a horizontal line? Right, it still would only hit in one place. Right, down here it kind of looks like that's maybe leveling out as this is going here, but it is going down and out. It's not staying level. It's going ever so slightly down and out. So that would be a one-to-one function, right? So it's a function, but it's also a one-to-one function. Okay, and remember the reason why we're wondering about if something is one-to-one or not is because we can find the inverse of one-to-one functions. If they're not one-to-one, then we can't find the inverse of those functions. Right? So let's look at just a couple of different ways that you might be asked to look at these. Okay, so I'm going to look at this first one here. So it says, find the inverse of f of x equals 3x plus 4 in two ways. Okay, so the first way is we're going to use tables. Okay, so what I want you to first do on this, I'm going to make a little table up over here. All right, and I'm going to have my x and my f of x. And I'm just going to put two different points in. I'm going to pick my x's. It doesn't matter what x's I pick, okay, because this one is invertible. I can find the inverse of it. It is a one-to-one function. That's giving me this function that is one-to-one. So let's just put in, what if x was 0 and x was 1? So I want you to figure out what f of x would be for both of those. So finish filling in that chart. Okay, so I got when x is 0, f of x is 4. When x is 1, f of x is 7, right? So again, remember that if I know that, right, I know some points, then I don't need to worry, you know, like if I just was asked, let me try this. So if I have x and then the inverse, right, of f of x, and if I just asked you, what is, so if this is 4 and this is 7, right, what would my answers be? So if I know x is 4, right, what would I get for my inverse of f of x?
Zero.
Yeah, remember I'm just switching those inputs and outputs when I'm using like a table, right? So I don't even have to, you know, like if I know some points on here, right, then I know if I switch those will be some points on my inverse function, okay? So sometimes you'll have some questions that are kind of like this, where, you know, they might not even give you like this function here, they just give you a table of values. and then you're just trying to figure out what that is. And just remember, you're just switching the x's and the y's. Okay, but the other way to do this is if we're trying to find the inverse of this exact function, that f of x equals 3x plus 4, we can do this algebraically. Right? And we do that by, there's basically 4 different steps that we're going to follow. Okay, so let me write down this function again that I'm looking at. So I'm trying to find what is the inverse of this function. So the first thing I'm going to do is change my f of x to y. Right? So it says y equals 3x plus 4. Right? So I'm just going to write maybe a little notes over here. Right? Change f of x to y. Right? And then I'm going to switch my x and y's, just like we were doing when we had ordered pairs, right? If I switch those x's and y's, then I know what that inverse is. So I'm literally switching the x and the y here. So I'm going to have x equals 3y plus 4. Right, so your next step, right? So the second step is switch the x and y. And then you're going to take this, after you've switched it, and you're going to solve that for y. So I'm going to start by subtracting my 4 over, because I'm trying to get y by itself. So I get x minus 4 equals 3x, or 3y. And then I need to divide both sides by 3 to get y by itself. Okay. Now you can leave your answer in that form, but oftentimes, it's going to be better to, think of this as you're dividing both of these by 3. So this is the same thing as saying x over 3 minus 4/3, right? Because I'm dividing both of those parts by 3. And then the last step, so after I solve it, then I need to write it in inverse notation. So I'm just going to write down inverse notation. So that means, so this equals the inverse of f of x. Right? So you got to write it as that f to the negative 1 power of x. Because that shows me that this function that I found is actually the inverse of the one I started with. Okay. What questions can I answer about that? Making sense? Okay, were there any questions that you had on 8.1 homework that was kind of tricky or that you weren't quite sure about that you wanted to ask? So this is all still on 8.1. So 8.1, we talk about these inverse functions and also composite functions. Okay. All right, well, let's go, let's start talking about the, so in 8.2, we're going to be talking about exponential functions. Okay, and so one of the big things that it's going to ask you to do on here is it's going to ask you to graph, right, these things. And so, didn't want you to have to do, so let's try, let's just do all of these, but let's just do it down here. So I just make kind of a little graph. You don't need to make this smaller one here, but just make a graph that kind of is moving, let's see if I can, it's a little bit smaller so you can see a little bit better. All right, so we can see on the x-axis it's moving by 2s, and on the y-axis it's moving by 4s, just to make it a little bit easier. So I think give you a second to draw that little grid. Okay, so I'm going to first start by plotting the points that are given here. Sometimes it's just going to tell us, you know, what x is, and we're going to have to figure out what f of x is, and we'll do that down here on that next part. But let's just start putting these points in so we can kind of see what's happening. So 2, you know, when x is 2, or f of x is 4, so I'm going to go over 2 up 4. Right, and there's a point. Then over 1 up 2, so that's going to be about here. Right, over 0 up 1, so maybe about here. Right, and then over negative 1 up a half. So look what's happening here. Right, you can see how it's getting really, really close to that x-axis, but it's actually never going to touch it. Oops, what happened here? About here. So it's getting closer and closer to this x-axis, right? You can kind of see on the bottom there. But let's not draw what it looks like quite yet. I want you to go ahead and figure out, okay, so if our x is 3, right, then what would f of x be? Well, 2 to the 3rd power, 2 times 2 times 2 is 8. So my next one would be over 3 up 8, so about there. And then when I put 4 in, 2 to the 4th power, 2 times 2 times 2 times 2, right, 4 times is going to give us 16. So over 4 up 16 would be about here. So notice how this is getting really, really close to this x-axis, right? But it's never going to touch it. So we call this an asymptote when we get really, really close. I'm going to put like a little dotted line here, and you'll hear that asymptote. So it's getting really, really close to the x-axis, but it's never, ever, ever going to touch it, okay? And this x-axis is also, we could call that the line y equals 0. And on your homework, sometimes it'll ask you, it'll say, what is the equation for the asymptote? So in this one, you might not be able to type in x-axis, you'd have to say y equals 0, but it's the same thing, right? Y equals 0 or the x-axis. And then let me just kind of connect these dots together so we can see what it looks like, right? It's getting really, really close down there, but it's never going to touch, and then it just kind of takes off, right? And it's going up and out kind of forever here. And that should look a little bit more smooth down here than I have it. Okay, and then I'm going to put an arrow going in both directions because I want to see, yeah, it's going to go out to the left forever, but as it's going further and further to the left, it still is never, ever, ever going to touch that x-axis. It looks like it's going to touch it, but it gets so close and never touches it. All right, and then out to the right, it's going up and out forever. And so I need another, make sure I put my arrow on that as well. Okay, so that's kind of what these exponential graphs look like. They start off kind of, you know, just really not, you know, building at all, and then they just take off, right? And, you know, and that's, you know, exactly what has happened with the coronavirus, right? When we're talking about, you know, the spread of a virus or like the growth of bacteria or anything like that, they grow at an exponential rate. And so, you know, it just, you know, seems to start off kind of slow and then just takes off. It's kind of crazy how that happens that way. Okay. And then So I want to compare that with this next graph here. So remember, the one that we had before was 2 to the x power, but this time we now have a fraction, and we're saying 1/2 to the x power. All right, so that 1/2 is being raised to a power now. And I want you to plot those points and see what this one looks like. Okay, because that 1/2 is doing something very specific to this. So go ahead and just try and make a quick sketch with the points that are given there to you. Okay, those first 5 points should look something like I have down here in purple on the graph, right? But I want to find 2 more points. What happens when x is -3 and what happens when x is -4. So remember, when we have, a negative exponent, what's really happening is you're flipping it, right? So you really have 2/1, right? It flips inside there, and then it's raised to a positive exponent. So that would be just 2 to the 3rd power, which is 8. Right? And similarly on this one, since it's a negative exponent, we're going to flip what's inside and then raise it to a positive 4th power. So that will give us 16. All right, so when I'm looking at this, I'm going over to -3 and up 8, right? And then over -4, up 16. All right, so we can kind of see, again, do you see how it is again getting really, really close to the x-axis, right? Or that line y equals 0, but it's never, ever, ever going to touch it, right? So there is an asymptote there, right? So I'm going to put that asymptote, oops, I didn't see myself enough room there. Right, so asymptote. It's kind of a fun word to say, okay? So asymptote is the line that it's getting really, really close to, but it's never, ever, ever going to cross, right? And so that's that line down here, this little dotted line I'm going to put across there. And then our graph of it, right, is kind of going in this direction. So it looks kind of like our last one, that 2 to the x power, right? Like you look at our points, and we're like, yeah, those points are pretty similar to each other, but it's flipped over that y-axis, right? And so when we have something where the base of the exponent, so that 2 on this one, right? So when the base is larger than 1, right? Not equal to 1, but bigger than 1, then you have what's called exponential growth. Right, where it starts off really, really small as you're looking at it from left to right and then takes off. Right, so that's exponential growth when the base, right, that's the 2 on this one, is larger than 1. And down here, what happened was a little bit different, right? We've got now our base is 1/2. So in this one, when the base is between, right, 0 and 1, right, but not including 0 or 1, just in between 0 or 1. So if it's a fraction, right, then you have exponential decay. And we're going to talk about these more later when we are dealing with story problems that are dealing with exponentials and how we can look at the graph and tell if it's exponential growth that is happening or exponential decay that is happening. Okay. All right. So it's going to have you do a lot of graphing with, you know, exponentials and stuff. I want to talk about one that where maybe the, you know, the x-axis isn't our asymptote, because I don't want you to think that our x-axis is always going to be the asymptote, because that's not the case. Okay, so let's see if we look at something like this. So if I asked you to graph y equals 2 to the x power minus 4. Right, so think about, we just had that 2 to the x power, right? But we were going to think about what is that minus 4 doing on this now, right? So I could make up a table of values, right, to be able to, and I just pick my x's. I know on some of those x's were picked for you, but you don't have to. You can pick any x that you want. Okay? These exponential functions are one-to-one functions. So any x is going to work for us. Okay? So if we pick, you know, something like, maybe I'll do -1, 0, 1, and 2. And let's look and see what that looks like so far. Okay, so if I do 2 to the -1 power minus 4, well, 2 to the -1 power is just a half, right? You have to flip that. And so a half minus 4 is going to give me -3.5. Right? If I put 0 in, 2 to the 0 power is just 1 minus 4. So 1 minus 4 equals -3. Right. Just going to do some of the work alongside here, but you could just do it out to the side if that's easier for you. If I put 1 in, so 2 to the first power and then minus 4. Right, so 2 to the first is 2, minus 4 would give me -2. Now let's put 2 in, so 2 to the second power minus 4. So 4 minus 4 gives me 0. Okay, So here's some points on it. We're going to go, we're going to plot these first and see what it looks like and see if we need to maybe plot some more points here to figure more out about it. Right, so if I go over -1, right, and then down 3.5, so 1, 2, 3, 4, so 3.5 would be about here. Right, over 0, down 3, so that looks about here. Over 1, right, to the right 1, and down 2. And then over to 0, so about here. Right, so I can kind of see the shape of my exponential starting here, right? But maybe I want to do just one more, so what is happening when x is -2? Maybe that would give me a little bit better idea. And what about when x is, let's say, 3? Actually, let's do -3. I'm going to go this direction first. So if we put -2 in, right? I mean, and you can just put this even into your calculator too. Some of you can, 2 to the -2 power and then -4, right? So 2 to the -2 power is 1/4. So that's going to end up giving us -3.75. Right, so you'll notice as I'm putting these numbers in, right, looks like it's getting closer and closer to -4. Do you see that? So what happens when we put -3 in? What do you come out with there? Change that to, if you have it as a decimal, it's going to be like -3.875. Right? You guys with me there? Are you trying to put that into your calculator? If you just put, in some of your calculators, you can just put this in, 2 to the -3rd power, figure out what that is, and then subtract 4 off of it. And it might leave it in fraction form, but you can click that button that switches between fractions and decimals and get that. Okay, but what happens when I put -4 in? Right, so 2 to the -4 power minus 4. What do we get there? So do you see how it's getting closer and closer and closer? Like it looks like it's getting closer and closer to this -4. And it's not a coincidence, right? That -4 that's here is actually kind of telling us where that asymptote is going to be. So my asymptote on this one is going to be at y equals -4. Remember, when you have y equals some number, that's a horizontal line right there. And so we know it's going to be getting really, really close, right, to there. So if I was just to make my, graph of it, it's going to look something kind of like this. Right? And so when you're graphing on your homework, it's going to first want you to put in what your asymptote is. Okay? Let me see, I might just bring up one of these really quick on the homework, just to make sure everybody. Can't remember which question it was. Just 1 second. Okay, so maybe let's do this one. Oops. So you can kind of see. Oops. Not that big. All right, so this one looks a little bit different, right? So we have 3 to the x plus 2 power, and so that's different than what we have on this last one, 2 to the x minus 4. So the subtracting 4, right, is all after it, and that's where my asymptote is, right? So what happens on one like this, right, 3 to the x plus 2 power, right? And notice, it's like, well, let's see, this side here. So write that down somewhere, that f of x equals 3 to the x plus 2 power. It's not going to really let me. I'll come back to that in a second. Right. And so sometimes students are kind of wondering, how do I know what values, like good values would be to, to choose for my x's? Well, when you have an exponent, like the x plus 2 is all part of the exponent, right? And so a good rule of thumb is to kind of use, what would make that x plus 2 part go to 0? So meaning if I had x as negative 2, right, that would be kind of where I want to start on that. And then I'd want to pick, put like maybe, a couple in each direction. So that's a good way to pick where to start your x's out. So when you graph it, you can kind of have an idea of what that looks like. Right? So when I put 0 in, right, so I put 0 in place of my x, 0 plus 2 is 2, right, so I'm really just doing 3 to the second power is 9. Right, then I'll put my negative 1 in next, 3 to the negative 1 plus 2 power would just be to the first power, so it's going to give me 3. Right, when I put negative 2 in place of my x, negative 2 plus 2 is 0, so 3 to the 0 power is 1. And then if I do negative 3, right, I'd have 3 to the negative 1 power, which is 1/3. And then 3 to the negative 4 plus 2 is the negative 2 power, which is 1/9. Right. So where would my asymptote be on this one? Can you tell what it's getting really, really close to, but never going to cross? It's kind of like this is saying, 3 to the x plus 2 power plus 0, right? Because remember I said this part, right, this minus 4 part was kind of telling us where that asymptote was going to be. But we don't have one of those on this one, so that means my asymptote is just at that x-axis. It is here at y equals 0. Right? It's getting really, really close to it, but never going to touch it. So let me go back to this a little bit. Homework question. Where did it go? Oh, here it is. All right, so when I'm trying to draw this on here, notice that it's, you know, you've got to pick where the asymptote's going to be first, which is going to be, oh, wait a minute, this one didn't have you do that. I guess if the asymptote is somewhere other than the y equals 0. Whoops, that's not what I wanted to do. All right, so then I'd want to just put in, you know, 2 of the points on there. So maybe I'll just do -1, 3, so over -1 up 3. No, I think it wants me to do that other one. Sorry. This is sometimes a little bit different on these. I think you actually have to start with that one that I was talking about, that -2, to make sure, like, whatever makes that 0. So if I do over -2 up 1, that's here, and then I can pick one just on either side of it. So over -1 up 3 will be there, and then it can kind of see that. So you kind of have to pick the, you know, the question, or the one that I was saying first, whatever's going to make it 0. So pick that point first, and then pick one of the points next to it, like close by it, and that will make it easier for there. So it'll take a little, maybe a little bit of playing around with on some of those, but if you have questions specifically on, you know, graphing them, I don't want you to get frustrated if you're like, oh, I've been trying this over and over again and I still can't get it to work. Like, reach out to me, right, and ask me, because I can help you, you know, help clarify something really quick that will get you on your way, so you won't be feeling so frustrated about that. Okay. Yeah, we didn't take a little break here. I hope you guys, if you needed to, get up, take a little break and stuff. You know, it's been kind of a long thing here. There was just a lot to cover today on some of this, and not even sure if we're going to get much into 8.3. But I did want to talk about, there's going to be some story problems on 8.2, which are dealing with compound interest. And really, they're going to give you the problem, and then you just need, or you have an equation that you can just, you know, plug stuff into and get those. So, so don't let those kind of freak you out at all. You're just kind of plugging numbers into those that they give you.
Is that a formula that we need to write down?
Yeah, I would make sure that you know that, because I definitely would make sure that you have it on your little note, you know, the note paper that you have for the test, because, yeah, sorry, I'm just looking at the ones that they had on here. Were there questions on some of those from the homework that they were kind of some of the ones down here? All right, maybe we'll talk about this one, just because this one can get a little bit crazy on here too. So on this question, let me see if I can make it bigger so you can look at it. All right, so from this one, a bank features a saving account that has an annual percentage rate of 4.6%. with interest compounded quarterly. So first of all, you need to make sure you understand what it means. You know, it'll say, you know, quarterly, and that's 4 times a year. If it says monthly, then that's 12 times a year. If it says daily, that's 365 days in the year. So make sure you understand what it's talking about when it's saying, compounded quarterly, right? And it says Brian deposits $6,000 into the account. What value should he use for P, R, and N? So meaning on this, right, we've got to kind of look at this. So P, right, is just his principal, right? So he deposits $6,000 into the account, right? But the interest rate isn't just going to be this 4.6% because that's what it would be annually, but it's being compounded quarterly. So we're going to change that 4.6% to a decimal. Let me write on here. All right, so we're going to move that decimal point 2 places to the left, so that's going to be 0.046, and then we need to divide that by 4 since it's quarterly. So I'm going to try and write it down over here so you can kind of see what I'm talking about. So when we're trying to figure out that R, right, and it tells us it's 4.6% annually, we've got to move that decimal point, right, always 2 places. So it's going to be 0.046, right? That's what it would be annually, but since we are doing it 4 times a year, we're going to divide by 4, right? So when I put that in my calculator, right, 0.046 divided by 4 gives me 0.0115. So that's what I want to put in. That's what I want to put in here for my R. So I'm not going to put the 4.6, and that's where some people get a little bit confused. So is that making sense, what I'm saying there? Whoops, did I forget a 0? I did. All right, so I just took this percentage, right, changed it to a decimal, and then divided it by 4 because it was quarterly. If it was monthly, I'd divide it by 12. If it was daily, I'd divide it by 365, okay? And then N deals with the number of times that it's going to be compounded, right? And so that's, wait a minute. Is usually the number of times compounded. Now I'm not. Now I'm kind of second guessing myself. Those of you that have done it, is that what you had to do on there? Because usually they're wanting you to put what the interest rate is divided by your N. All right, but then our N. Has anybody tried it on there? Let's see. Let's put this in.
Yeah, I'm pulling it up right now to see what I did.
Let's see. And then if we use that formula, right, remember the formula for that is A equals P times 1 plus R to the T power. That's not my favorite. That's the one that the book shows and stuff, but I don't know. I actually don't like using that one as much because that's really only if it's for the 1 year. So the one they give you is A equals P times 1 plus R to the T power. But depending on the number of times it's compounded, right, like you really have to multiply this by N, and you have to divide your R by N to really figure out what those things are. And so when I try and put in what I've been given there, So I'll do 6,000 times 1 plus that crazy decimal that we had before. Right, all raised to the n times t power. It said 7 years, right? But we also have to take into account the number of times it's compounded, which is 4. And so we're really raising this to the 28th power. So if you were putting it in your calculator, you could put it in like that, but I'd go one step further and just do 1 plus this, right, is 1.0115 raised to the 28th power. And most of your calculators will, be able to do that pretty well. But if not, just follow those order of operations like we've talked about before. And then you always want to make sure that you're rounding your answer to the nearest penny unless it tells you otherwise. So when I get my answer, I get like 8,264.110002. Right? Is that what you guys came up with? Anybody try that one? Hello, hello. Okay, so let me give you just a minute and try it and see if it's making sense to you or where I can clarify things for you on these.
Hey, Becky.
Yeah.
On that R,
Yeah.
you should point 0.046.
Okay. So it's not wanting you to figure that out on here. See, on different programs, they have you figure out what the actual rate is that you're using. But when it asked for what n was, I was like, that's kind of different. So like that. But then you've got to make sure that you remember that you're dividing by that and multiplying by it. So like I said, let me go back to my other the other page here, right? So let's look at this part. So this is the formula that I would say to put down. This A equals P, and then in parentheses, 1 plus R over N raised to that NT power. So write this down as compound interest formula that you'll want to have for the test. All right, so A equals P times 1 plus R over N to the N times T power. And then I'm just going to quickly just say on here, because I think it will be helpful for you probably if you just write down, right, the P is the principal, or that's your start amount. All right, the principal. And then the R is the interest rate. N is the number of times it's compounded in 1 year. And then T is the time in years. So I would write down this formula. I think it's better than the one that they usually give. I know that the book gives that other one that I was saying down there, and I think it just gets a little bit confusing because then people forget to divide by the n and multiply by the n on those. Okay. All right, were you guys able to put that into the formula? Did you come up with that number, or did you come up with something different? Just so I can see where I might be able to help you. I know every calculator is a little bit different too in trying to put those in. And then just make sure that you round, once you get your answer, round to the nearest penny, right? So we don't want to, you know, have the stuff after the ones. I mean, we're looking at saying, okay, well, I want to round to this place value. 0 is not big enough to round anything up. So I'm just going to be leaving it as the 11 cents. Right? That's how I'm going to leave that. So $8,246.11 is how much money you'd have in your account after 7 years. Right? With those different stipulations there. All right, so that compound interest formula is actually pretty cool to understand and to know more about. So make sure that you kind of, practice with that one. So that tends to be one, type of question that they ask a lot. And I wouldn't be surprised if something like that showed up on the final exam. All right, we have just a few minutes, and so I'm going to just start a little bit into 8.3, but we're going to have to do most of it next time, so don't worry about getting 8.3's homework done. This time you'll have until Thursday to get it finished, since we didn't get through everything today here. Right, let me show you. I want to kind of have you do something. So everybody get your calculators out, because there's something kind of fun that I want you to try doing with me so we can kind of understand what we're doing. Because remember, whenever there's a way to do something in math, there's always a way to undo it, right? And so we want to, kind of talk about undoing exponential functions. Right? Because that's what we just got done talking about, were those exponential functions. So I want you to think about this question that was just posed right here. I'm going to write it down again. So if you're trying to figure out 10 to the what power, right, equals 2,500. Okay, so I want you to get your calculator out. And I want you to, start, trying to figure some things out here. But let's first look at part A, because it's saying, why must 2,500, or, why would the power of 10, the exponent, have to be between 3 and 4? So let's think about powers of 10, right? I know that 10 to the first power is 10. I know 10 to the second power is 100. 10 to the third power is 1,000, and 10 to the fourth power is 10,000. Right? So I'm looking to see, I'm trying to figure out 10 to the what power is 2,500. Right? So see how 2,500 would be somewhere in between, right, my exponent of 3 and my exponent of 4. So I want you to try and figure out, all right, what power, and try and get as close to 2,500 as you can. So we know it's going to be 3 point something here, right? And I want you to start off maybe with 3.3, right? So if you try 10 to the 3.3 power, just try that on your calculator, right? I'm going to write this over here. So 10 to the 3.3 power. If I do it on my calculator, gives me like something close to that, right? So I'm thinking, all right, well, that's, you know, like, what if I try 10 to the 3.4 power, right? Because I'm trying to get close to 2,500, and all I'm at right now is 1995. So what would 10 to the 3.4 power be? Right, well, that puts me over 2,500, right? That gives me like 2,511. So I'm like, okay, it's got to be somewhere in between 3.3 and 3.4. So now I'm going to just start, you know, doing some other things. So 10 to the 3.3, maybe 8 power. Right, what does that give me? Get about 2398. All right, so keep going, and I want you to go out 3 decimal places, right, to get something close to that 2,500. Tell me what you can come up with. So 3.3 what? Gives you something close to 2,500. Okay, to go out 3 decimal places, so 3.39 what? So get even a little bit closer. 10 to the 3.398. So Danielle, what did you get when you rose it to the 3.398 power? Okay, so, right, it's pretty dang close, right, there. So that looks really good, right? So 10 to the 3.398. And the more decimal places I put after this, the closer and closer I can get to that 2,500, right? And, you know, so that's kind of like what we're doing when we're trying to figure this out. So last time, remember, we were kind of doing, 10, and they gave us what the power was, and we figured that out, right? But now, right, we're trying to figure out what that exponent would be if they give us the answer, okay? So let's try another one. I want to just kind of make sure you're seeing what we're doing here. So let's look at this little chart here. We're not going to do all of these, but so on this one, let's try this one with 333. So I'm trying to think of 10 to the what power, right, gives me something close to 333. All right, so go ahead and try and figure that out. And on this one, again, I want you to take it out 3 decimal places. So 333, right, is going to be, my exponent's going to be between 2 and 3. So I know I'm going to be 2 point something, something, something. All right, so I want you to figure out what those 3 places are after that decimal point. Okay, so Amber, what did you come up with? So 10 to the 2.53 power. What did you get there for your answer? I think you must have left off a number. Then I think you did, because to the 2.53 power would be like 338. Right? So I meant off of your. Okay, so David's saying 2.522. Somebody else said 10 to the 2.523. Right? So let's look at a few of those. All right, so yeah, so 2, yeah, right, Amber. Okay, so you came up with 333.42, but then David, what did you come up with when you rose it to the 2.522 power?
$332.659.
Okay, so that would round up to 333, right? So it's kind of like, you know, it's really between probably, you know, these two. If we took it out one more decimal place, would actually be more accurate, right? But what I want you to see with this, right, before we go, is so this is one way we could find the answer to these, like trying to figure out, you know, 10 to the what power gives us this number, right? But that's kind of a tedious way to do these things, right? To have to keep using your calculator to say, okay, no, I could get closer to that. I could get, you know, closer to that. But the other thing is we don't have to just use 10 as our base, right? Like, so on this one, it's saying, you know, 3 to the what power would get me close to 1,200, right? And so this means you need to kind of think about things that you know about powers of, you know, 3. Like, so we know 3 to the 4th power is 81. 3 to the 5th power is, wait a minute, 3 to the 5th. I'm thinking 5 to the 3rd. Sorry about that. Let me see. How do I erase that? Here we go. Okay. Sorry about that. So 3 to the 5th is actually 243, right? So I might have to kind of, you know, think about, you know, maybe if I did, you know, 3 to the, you know, 6th power next. See if that gives me something very close, right? Oops. And that's 729. So see, I'm not even there yet. So I've got to try 3 to the 7th and so on, right? So this kind of is, you know, it's a way we could figure these out, but it is kind of tedious to do this, right? And so what we're going to talk about next time is we're going to be talking about logarithms. And basically what a logarithm is how you undo exponentials. So you don't have to sit here and tediously like figure out, okay, you know, 3 to the what power gives me something close to 1,200, right? So now I want you to try in your calculator. Whoops, let's see, let's go back up to this one though that we did before, not the 3 power, because most of your calculators will only do logs in base 10. So what I want you to try and put into your calculator right now, find your log button on your calculator, right? And I want you to find the log of 333. Right, so find the log of this number. All right, so you guys see the log? See where log's at on your calculator? And notice that it gives you, right, 2.522444, right, blah, 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 blah. Right, so see how we could figure out what that is without having to do all this work of, okay, well, it's kind of close to that. Nope, now I have to go back a little bit. Now I have to go forward, right? So I can figure out what that exponent on this is supposed to be just by using that log button, right? And so that's what that log button is for. That's to help you figure out what exponent should that be raised to, right? So even like if we do this one, let's try this one also. All right, so you're just doing log of 314156. All right, so try that on your calculator. So that, all right, it's really 10 to the, and the answer they give you, right, is the exponent on that power of 10. So 5.497145, blah, 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 right? And it keeps going and going and going, right? But that way, right, it's so much easier to use those log buttons to figure this out, right? Does that make sense, kind of? Because I just want to make sure you understand what a log is, because I think with 8.3, a lot of times people get confused on it, not because it's difficult, but it's just, you know, trying to wrap your mind around, what am I really doing here? What am I trying to find, right? So when you're taking the log of a number, you're trying to find the exponent, right? Like in this one, 10 to the what power, okay? But we could also do things in different bases. 3 to the what power gives us 1200, but your calculator won't do that. Well, some calculators will, I shouldn't say that. Some you can put in what the base of the log is, okay? All right, so we'll pick up there next time and talk more about these and what logs are and what we're going to do with logs. Because a lot of the rest, you know, so 8.3, 8.4, and 8.5 all deal with logarithms. So just having a good understanding of what a logarithm is will be really helpful in being able to complete these. Okay, so I'm sorry there was so many notes today. I know I try not to do like so much talking, but I hope that was helpful for you.